Okay, for the last couple classes, we've been talking about the theory of significance testing. How do you set up the null hypothesis? How do you set up the alternative hypothesis? How do you interpret the p-value? And what conclusion do we reach once we have gotten our p-value? Of course, what we haven't discussed is how you actually calculate that p-value. And that's what we're going to get into today. There's two different processes. There is calculating the p-value if you're dealing with a proportion or if you're dealing with sample means. So today we're going to be tests about population proportion. We're going to check the conditions. We're going to conduct the significance test from bottom to top, and we're going to reach our conclusion. So earlier we did confidence intervals. And remember, when we did confidence intervals, we said the idea that we're pretty sure that the true proportion is between some interval. Now we've talked about p-value. And now we're going to learn about one-sided and two-sided tests and how we get that p-value. Where does that p-value come from? How do we evaluate it? Now, so recall our basketball player who claimed to be an 80% free throw shooter. In an SRS of 53 throws, he made 32. His sample proportion of made shots, 32 out of 50, was 0.64, much lower than what he claimed. Does this provide convincing evidence against his claim? So the first thing we would do is we would state our null hypotheses, and we would define our parameter. Now, the next thing up is we have to check the conditions for the test. All right. All our theory is for calculating p-value is based off of a normal distribution. The sampling distribution the sampling distribution has to be approximately normal. And so how do we check normality? Well, hold on, announcement.
Shelley Carranzo, please come to the main office. Shelley Carranzo.
So, and remember, the sampling distribution of p hat is approximately normal if n times p is greater than 10 and n times 1 minus p is greater than or equal to 10. Now, things are going to be slightly different than when we did the confidence intervals. Because when we use the confidence intervals, we use p hat, because that was our best estimator. But here, we're assuming that the null hypothesis is true. So instead of using p hat, we're actually going to use the p from our null hypothesis, which we're going to call p naught. So n times p naught has to be greater than or equal to 10, and n times 1 minus p naught has to be greater than or equal to 10. The sample still has to be random, or we can't make inferences about the wider population. We took a sample, and we're trying to say that our sample is indicative of the entire population. We're trying to make inference about the entire population, not just our sample, but we can only do that if our sample was randomly selected. And lastly, it has to be independent. The sampling distribution standard deviation, the standard deviation of the sampling distribution gets wonky if we sample more than 10% of the population. So we have to check these. And so random, well, we can view this set of 50 shots as a simple random sample. It is normal because, but it's close, right? 10 is greater than or equal to 10, but it's close. And then independent, well, there's an infinite number of foul shots, so we definitely sampled less than 10%. So that was what we checked. Now, here is what's happening. There is a sampling distribution of p hat. And remember, the mu p hat is p. And the assumption or null hypothesis is that p equals, remember, h naught was p equals 0.8. And so by random chance, we're going to get if we did every possible sample, we would get the sampling distribution here. And there is our center, and there is our standard deviation. Once again, we're using P naught here to find our standard deviation of our sampling distribution. And we get the distribution you see here. Now in our sample, we actually got a p-hat of 0.64 right here. And so the question is, what is the probability that I would get a value of that or lower? And so what we would do is we would go to our z-table. And we would ask ourselves, what is the probability of getting that value or lower? And actually, I'll show you this because we got used to, instead of you can use the table, or you could use your calculator. And so we have a normal distribution here up on the board, so we can do a normal probability calculation on it. And I'll bring that over here so you can see. So we're going to go, not here, sorry. Just real quick, it is a normal distribution. And we want, if we drew our picture here, so if we think about it, we want the area between negative infinity and 0.64 in a distribution with a center of 0.8 and a standard deviation of, well, I can't see it, 0.0566. And so the area of this little shaded region here is 0.0023. Isn't that what I saw? Sorry. My calculator disappeared. Yeah, 0.0023. So that's the area. So what that is saying, that number, this is our p-value. Our p-value is the probability that we would get a value of 0.64 or lower in a random sample of 50 shots in a population where the true proportion is 0.8. And the chances of that are very low. If we look, that p-value is certainly below our baseline alpha of 0.05. So the question is, does this provide convincing evidence? And this is just summing up what we do. The other way you could do this is you can create a test statistic. So instead of doing the normal probability like I just did, you could do a test statistic, and that's going to be z. And z is our stat, 0.64, minus our parameter, which is our what we think is true of the population, divided by the standard deviation of the statistic. And this should look familiar because this is this formula for z-score. And so when we do that, we get a z-value of negative 0.283. And you can use that negative 2.383. You can go into your table A in your book, and you can be like, okay, what is the probability that z is less than or equal to 0.283? And you get that 0.023, which is the exact same number I got by doing it on my calculator. So which way is correct? And whichever one you want. So we got that nice low value. We reject the null hypothesis because our p-value is lower than our alpha. We have statistically significant evidence that the player's free throw percentage is less than 80%. I don't know what that extra zero is doing in there. I'll go ahead and delete it right now. We have another announcement. Let's see whose mom's here to pick them up.
Shelly Carranza, please come to the main office. Shelly Carranza.
Well, Shelly better get down there. She's going to get left behind. So, here is the process. When you do a one sample z-test for proportion, you're going to state your null hypotheses and define your parameters. Then you are going to state your inference method, and you are going to check the conditions. Then you are going to compute the statistic and compute the p-value. And then lastly, you are going to include. You're going to interpret the results of your text in context of the problem. And we know that FRQ questions are scored 0 to 4. And I'll tell you right now, on these type of problems, there's 1 point, there's 1 point, there's 1 point, and there's 1 point. And so if you want to get a 4 on this question, which is not hard, you just have to do those 4 things. You need to correctly state your hypotheses and define your parameter. You need to check the conditions for the test you're going to use. You need to compute the test statistic and find the p-value. And then you need to write your conclusion, the fail to reject or reject the null statistically significant evidence, and have the context of the question. And for my non-native speakers, the context of the question is repeating the question back to them that they asked. And this is what I was saying earlier, is that we're going to use P0. We're going to use the p-value given by the null hypothesis, not the p-value that comes out of our sample. Because the whole theory of this test is designed around the idea that the null hypothesis is true. If the null hypothesis is true, then that is the value for P. Remember, P0 is not P hat. And you check with P0 when you do your n times P and your n times 1 minus P. Now, the only tricky part of this is that your book really only gives this. When you look something up in the book, it'll give you that area. So if you want this area, using the table of values, you would have to find the area I'm shading here in red and subtract it from 1. And if this area is x, then this area is 1 minus x. If it's a two-sided test, and this is where it gets a little trouble, if your alternate hypothesis is simply not equal, what you have to do is you have to find this area out of the table in your book and then double it. But the formula for finding any of these z values given is right here. And this is not going to be on the AP exam because you're going to get all the different pieces. They'll have defined it in pieces, and we'll go through, I'll show you a formula sheet in class, and there'll be a formula for test statistic, which is written out in words, and then there'll be a formula for mu hat. So, they would give you z equals, hold on, let me get it right. You know what, we'll go over it in class. We'll go over it in class, because otherwise it's just going to be confusing. The last thing, and this is kind of, we talked about this a little bit last class, is that a confidence interval gives a lot more information than a significance test. A significance test gives you a yes or no answer. Is this better or is this worse? But it tell you how much better or how much worse. And so a lot of times a confidence interval will give you more information. And this is just a summary of everything we've done here. But we're going to be basically from the ground up doing a lot of these. The key thing here is this. When you do these type of tests, you need to do this is the 4-step process. And you got to do this. And we're going to have to learn this format. We're going to practice it ad nauseum in class so that it's automatic. Because this is, once we learn this is an easy 2 to 3 points. And really, if we know what we're doing, an easy 4-point question on the AP exam. And if we can get a few 4s on that FRQ, then we're well on our way to a 4 or 5. So I will see you next class.